Good evening. My name is Bejide Oluwafemi David. You are welcome to my channel. This evening we want to learn how to perform spatial interpolation. I have made a video on how to perform this analysis with ArcMap. But for the sake of those people that are using ArcGIS Pro, this is the reason why I'm making another video. Okay? So what do we mean by spatial interpolation? Spatial interpolation is a method for estimating the values of a variable at unmeasured location based on values from nearby measured location. So what I was trying to say in essence is that it is a process or is a way of using known values to obtain or predict unknown values in space. Just like our mathematics, we always work from known to unknown. Now let's see a little practical application of this before I move forward with my explanation. All right, let's say for instance I want to create a noise map, not by noise pollution. So we use an instrument called a decibel to measure the noise frequency and how strong or low a voice or a noise is in the environment. So the issue is that in a local environment we can only pick the noise pollution within some point or about some point. Or let's say we are working at a very large environment, we cannot get to all the places to pick the noise, the frequency and the frequency of noise. So what we do is that we just pick some of the samples to represent the whole area. So we now use these samples to predict or to interpolate. All right, we have types of interpolation. The first one is inverse distance weighting. The second one is kriging. The next one is spline, and the fourth one is trend surface analysis. But for the sake of this practical application, we are going to be working on the first one, which is inverse distance weighting. Now let's see some application of spatial interpolation. It can be used in environmental science, as I've said earlier on, to measure pollution levels. We can use it to map temperature, precipitation, soil properties. For instance, let's say we want to make a soil map of an area. We want to produce a soil map showing the soil pH, the soil organic content, or the nitrogen in the soil. So what we do, we pick the samples at some locations, then we plot them and we interpolate to get the whole map of the place. We can also use it in geology, in mineral exploitation. You pick some points, the values of mineral that is found in one place, and you use those ones to get where it can be found again. We can also use it in agriculture, whereby we can use to estimate soil moisture, the soil nutrient and everything. Okay, we can also use it in urban planning, in estimating city air quality, noise level, or city infrastructural condition. So we can also use it in estimating the spread of diseases or pollutants in an area. But for the sake of this training, we are going to be using this method in urban planning to estimate the air quality. So the air quality we'll be dealing with is the particulate matter 2.5 PM 2.5. Okay, so we are going to launch our ArcGIS Pro now. Okay, this is my ArcGIS Pro. So this is this software is ArcGIS Pro version 3.4. Okay, I will go to map. Now the first thing I will do is to bring in my area of interest. So let me go to the area of interest. Okay, is inside my computer. Pollutant asthma. Okay, so let's bring in pollutant. Okay, sorry. Okay, so this is my study area. I'll click on it and bring it to the environment. As it is loading, while we wait for it, now we have to process or to organize our data. we have to organize our data. So let me just open the data for us to see. So this is my study area. It's made up of 3 states in Nigeria. We have Ekiti, we have Osun and Ondo together. So this is Ondo, this is Ekiti, this is Osun. All right, let's go to the data. Let's come to pollutant data. I want to open this data. Okay, let's see what is inside. So is the PM 2.5 values of some points in those states I mentioned. Okay, so these are the locations of the place, or the places where all those values were picked. We have the EXUT, Ekiti State University Teaching Hospital. We have FMC Do Ekiti. We have General Hospital Ikere. So all these coordinate points were obtained, and the value for each year was collected. We have the PM 2.5 value for 2018, 19, 2020, 2021, and 2022. We'll be working with 2018. So as we can see in this data, also we can see that we have the longitude and latitude, the XY coordinates. So one thing I want us to know here is that whenever you arrange your data like this, we must save it as a CSV file. So we save as CSV file. So let's come to here. So it is already in CSV file, so comma delimited. Okay, we can press save. So press replace. Okay, because I've saved it earlier on, don't mind it, you press yes. So let me close the data. All right, so I'm going to bring in the data into ArcGIS Pro environment. So what I will do is, you can press this, you can press this, so any which way it goes. So let me just press XY data. Okay, while it waits, you can also from here add your data. So when you add your data, the data CSV, press OK. Okay, so that will bring my CSV data into the environment. So I want to plot it to XY coordinate. So the system is running. So while we wait for that to run, make sure you subscribe to my channel. If you follow up, you gain a wealth of knowledge I've accrued over time. So it is running now. Okay, it is my data is added now. Since it is added, we can now select it from here. We have the data. Okay, now automatically it's going to derive out the X and Y coordinates. It's going to bring out the X and Y coordinates. So it's still running. All right, now we can see this is the longitude, this is the latitude. We can press run. So with that, it's going to display our data as XY data. So while we wait for it, okay, that's done. So we can see these are the point locations whereby all those values were obtained. Let me take this one to hollow so that we'll be able to see this. Okay, all right, now the next thing I want to do now is to do my IDW interpolation, that the inverse way, the inverse distance weighing. So we come to our analysis, come to tools, then we can type IDW. So press enter. So we now select the IDW Spatial Analysis tool. So we take this point, the point data we have displayed, then this Z value. The value we want to is this year 2018. So we now come to environment. Once we come to environment, we come to raster analysis and select mask study area. Then the processing extent. The processing extent, it will be what? Study area. So the study area will be using as a processing extent, and also our raster analysis, the mask will be what? Our study area, which is this place. So we can press run. So it is running. Let's wait for it. Mind you, once again, you come to raster analysis, you put study area under your mask, this place. It is very, very important. Under this mask, make sure it is your study area. then order this processing extent this place, make sure it is your study area. So this is our inverse distance weighing IDW. So what it's trying to tell us is that all these places, they have the same value. So it was only this point that was picked, so but it was able to predict all these places. Then we can see like that. So we can just come to symbology and classify it into 5, so that we can have let's put it as 5. So this is our inverse distance weighing. So we can design this map by come to insert, come to layout, to press this. So as we press that, you come to, let me wait for it, you come to frame, you select this, so you drag it, as we drag that. Okay, so we can off this if we want or not. Then we can add we can insert our true north, everything into it, and embellish the map very well. So we can insert our legend. So let's choose this, can do like that. Okay, so then we can do we can insert our scale bar. So that is how to produce the inverse distance weight. So we can see now we just picked some point and we're able to get the value for other places. Make sure you like this video and share. Thank you.